Alright guys, so where we left off that we didn't get to before the end of class was this one last worksheet that we needed to go over. It's called Similar Shapes, but the way I refer to it is scale factor. So you have two similar objects and you know they're similar. So, for example, I have a big Rubik's Cube and I have a baby Rubik's Cube. Alright? They have different dimensions. So actually, using those as my example, I'm actually going to start with 2 first because I think it is a little more straightforward. Alright? So let's look at this one. You have 2 figures below that represent 2 similar solids, and you want to find the value of the missing dimensions and support your answer. Okay, so first off, the key is that they are similar. Alright? So the first look over that I give this, I have this side, and I need to figure out what W is and what H is, and then I have these 3 sides. Alright, so my first thing that I see is I have inches, 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 and then I have feet here. Well, we can't do comparisons among different units, so I need to either convert the 3 of these to feet or 1 of these to inches. So I'm going to go ahead and save some time, and I'm going to convert that feet to inches. I know that there are 12 inches in 1 foot. So my feet cancel, and I get that this side is 9 inches. Alright? So instead of feet, I need to recognize that I need consistent units. So I'm changing the 1 instead of changing 3 different ones. Alright? So that side right there, which is 0.75 feet, is also 9 inches. Alright, so now I'm ready to look at them and compare. Alright, so if I know this side is 9, and this is the same side on the similar figure, alright, I can determine the relationship or the scale factor, which is otherwise known as K, right? When I go from 9 to 18, what I do is I multiply by 2. I'll make that an X. I can also go the other way. If I go the other way, I'll do that in a darker blue. If I went from 18 to 9, I divided by 2. Alright? Oops, not 9. 2. Alright? So, the order that you go matters. Alright? So my K is 2. Either I divided by 2 or I multiplied by 2. So, let's figure out these other sides. I have W. W, which I'll color orange, is the same side as this 24. So I'm going from big to little, so I need to divide that 24 by 2. So for W, we'll do it in orange, W is equal to 24 divided by 2, again because I'm going from big to little, so I need to divide by 2. So this is 12 inches. So my W is 12 inches. Alright? Last side, I have this side right here. This is the height, otherwise known as H. Again, I have the big side. I need to go to little, big to little. So I'm dividing by 2. 2 is my scale factor. So H is going to be 36 divided by 2, which you get 18. Alright? That's pretty straightforward. Now, we completed the problem They just wanted to know what the different sides were. All right, but I want to use this as an opportunity to show you that this scale factor can also be used to compare areas, and it can also be used to compare volumes. All right, so how you do that, again, remember I gave you this sweet formula sheet. If you go down to the part that says scale factor, right? This is for comparing two similar figures. When you're comparing a side to a side, just like we did in this problem, K, you just use K. K is your scale factor. Now, when I'm dealing with area, that's two dimensions, right? Length times width, base and height. That's an area comparison. So I need to take that K and I need to square it, and that will give me a comparison scale factor. That's again for area. Now, when you have 3 dimensions, you need to cube your scale factor, and that will give you a volume comparison. Okay, so here's what I want to do to show you what that means. Okay, see how I have 2 cubes? I got the little one, I got the big one, or big and little this way, because that's how they show you, right? I also have the 3 dimensions, 1, 2, 3, 1, 2, 3. All right, so let's compare the volumes. Okay, volume for the big is 18 by 24 by 36. All right, I plug that into the calculator. 18, 24, 36. I get 15,000. My volume for the big is 15,552 inches cubed. Again, because it's a volume, it's a cubic, right? Here we just had singular inches because it was just one side. Now I'm going to do the same thing, but with the little numbers. Volume of the little, that is 9. We have to use consistent units. 9 by W was 12, and the height was 18. Okay, so that gives me volume of the little, 9 times 12 times 18, enter, I get 1,944 inches cubed. All right, so I'm going to compare these 2 volumes here. All right, how I got this 2 is I put the big one on top of the little. All right, so for example, 18 divided by 9, 18 divided by 9 gives me a scale factor of 2. Okay, so this is 2 times, this length is 2 times bigger than that length. Or sorry, I mixed that up. This length is 2 times bigger than that length. All right, now what we're going to see when we compare the volumes, the volume of the big divided by the volume of the small or the little, we'll see how much bigger all these 3 dimensions are than the little. Okay, so let's put the numbers in. 15552 divided by 1944. All right, plugging that into the calculator. Divide it by the answer. Enter. I get 8. All right. So let's think about this. When I was comparing the side to the side, one length, one side to one side, I got K. My volume was 3 sides, so I should be able to take K, which is 2, and cube it, and that should give me 8. Okay, so let's just check it. 2 to the 3rd power is 2 times 2 times 2. Again, caret key, that could shortcut some time. That's that button right there. That gives you an exponent that you want other than 2. Enter, it's 8. So, what you need to know for the FSA, when you're comparing one side or a side to a different side among similar figures, all right, you need K. Say I wanted to do this top to that top, so I'm looking at an area, right? A length times a width. I need to take K squared. And when I'm looking at volume, that's 3 dimensions, 3 sides multiplied together. So that's where K cubed comes into play. So look at my hint. How did you compare? Did you compare big to little? Or little to big? Okay, the order matters, because it could be either 2 or like 1/2, right? This is the same as dividing. This was like multiplying, okay? So it's opposite functions. So this is key to success on this. Order matters. All right, so let's look at some other example problems on this one. Okay, I'm going to do 3 and 4. 3 and 4. So, for number 3, they tell you you have 2 cylinders. I'm going to go ahead and draw 2 cylinders because I like to visualize them. A and another one. The height of B is twice the height of A. Okay, so my smaller one is A, my bigger one is B. The height of A we'll call H. And I know that the height of B is 2 times the height of H. All right? So from that, my scale factor also known as K, is 2. So if I'm going from little to big, I multiply by 2. Little to big, I multiply by 2. They tell me that the volume of A is 13 cubic centimeters. And they want to know what the volume of B is. All right, so again, volume comparisons, you must consider the 3 dimensions, okay? So I don't want to use K, because that would be wrong. I need to use K cubed to solve. All right? So I know my K is 2. It's going from little to big. I have my little volume, 13 centimeters cubed. I want this volume. How much does that hold? Okay. So first I want to get K cubed. 2 cubed. We actually just solved that. 2 cubed is 8. All right. So I need to take 13 centimeters cubed, which is the volume of A, and I multiply it by the scale factor K to the 3rd, because again I'm using volume. So I'm going to multiply this by 8, and then we'll get the volume of B. So 8 times 13 is 104. Thus, the volume of B is 104 centimeters cubed. I know that's really tiny, so I'm going to zoom in for you. All right, the volume of B is 104 centimeters cubed. I took the volume, I multiplied by scale factor for volume, which is the cubic of one side. Because again, volume deals with 3 dimensions, 3 sides. That's where the K cubed comes from. And that gives me your volume for B. All right, let's look at 4. 4 is similar, but this time instead of having cylinders, we have 2 prisms. Make a little tiny one. Pretend these are exactly the same, like the Rubik's cubes. Let's figure out which one's the big and which one's the little. M and N are mathematically similar. All right. The volumes of M and N are 17, so that means M, the volume is 17 centimeters cubed. It's the smaller. And N, the volume of N is 136 centimeters cubed. The height of N is 18. 18 centimeters, that's my height. All right. Find the corresponding height of N. So I need this height. Okay, so to start off, comparisons, I can compare my volumes. Volume of N over volume of M. That's going to give me K cubed, because it's a comparison of volumes. So let's plug in numbers. The volume of N is 136 centimeters cubed. And the volume of M, Mary, is 17 centimeters cubed. So what that means, my K cubed is, let's see, 136 divided by 17 is 8. Oh, sweet. Because we've done that one before, K cubed, so I know that the cubic root of both of these, let me show you how to do that in the calculator in case you forgot. All right, I'm going to type 3 for cubic, and then remember we've been using this caret key. If I use the tiny, you can't really see, there's like an X outside of that radical. That means use the number that I just plugged in, which is 3. So second that's going to take the cubic root. I could take the 4th root, 5th root, whatever root. I just need to put that number there. All right, 8, enter. So I know that K is equal to 2. So what that means, when I compared the volumes, I went from big to little. Big's on top to little. Okay? Logically, I need to go from big to little here. I don't want to multiply by 2 because that would give me a bigger height. All right? So obviously I want to take this 18 and divide by 2, my scale factor, which will give me 9, not inches, centimeters. 9 centimeters as my missing height. So the height of M, sorry, I can't spell, is 9 centimeters high. All right, that's taking the 18 and dividing by 2, which was my scale factor. Again, I need to use just K because I'm comparing a side with a side, a height with a height, okay? One dimension with another singular dimension, all right? So this can be useful in saving you some time on the FSA, and it's something you could potentially see. Let's look at 5, Part A. I'm just going to look at Part A. All right. For 5, they tell you that an MP8 Max semi-truck diesel engine has a volume of this, 780 cubic inches. And then they have 2 smaller models. Okay. Which scale model H has the greatest engine volume? A 1 to 8 or a 1 to 24? All right, so this is actually a common sense problem. Yay! All right, so what I'm looking for here is I have 2 different models. One's 1 to 8 and another one is 1 to 24. And they want the greatest engine volume, okay, of these 2 models. So the common sense here is which ratio is bigger. So without doing any math, I know that a 1 to 8 is going to be bigger. Essentially, these are your scale factors. Okay? All right, let's get back and go to number 1. Number 1, there's actually 2 ways, 2 solutions, or 2 ways of looking at this problem. Okay? But they both deal with scale factor. So what they want you to say, you have these 2 diagrams, you have Earth and you have Mercury. They say, how many times will Mercury go inside the Earth? Okay, so that means Mercury is the smaller one. And Earth is the bigger one. Earth. Okay, so how many times will that one go in that one? All right, so the way they want you to solve it is I can get a K by comparing the diameters, right? That's one of the dimensions. So I'll put Earth on top, 7917.5 over Mercury 3032. So my K there, my scale factor, get rid of that, 7917.5 divided by 3032, enter. All right, that is approximately 2.61 blah 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 blah. Okay, that's my K. Now again, I'm dealing with volumes here, so I need to take this, cube it, and this will be the number of times. So I'm just going to keep that into the calculator and take it to the third, because these whole spherical shapes are volume. Okay, so it tells me that it would fit in about 17.81 or 18 times. Okay, here's another way you can look at it. Volume. All right, this section we've been dealing with volumes as well. So when you have spheres, The volume equation is 4/3 pi r cubed. All right, let's set up a volume comparison. Volume of Earth to volume of Mercury. I'm going to just stack the two equations. 4/3 pi. Let's do a quick calculation of my radius here. Earth 7917.5 divided by 2. That'll give me the radius. My radius is 3958.75, and I cube it. That'll give me a volume. All right, same here. When I'm dealing with volume, 4/3 pi. 3032 divided by 2 gives me the radius of Mercury, 1516. All right. So one reason I didn't just do it all in the calculator, see how these are going to cancel. They're on both top and bottom. And then I can do this. I can take my radii. So I've got one that's 3958.75, and I want to take it to the third because I'm cubing it. And I'm going to divide the other one, 1516, to the third. Ooh, look what I got. Exactly the same as when I calculated it up here. All right. If you forgot, you can plug those in. So this was how they wanted you to solve it, but this also works. Thinking about the problems. All right, that's one of the coolest things about math. Is there's several ways to solve the same problem, but don't get overwhelmed. Okay, whatever makes sense to you, that's what you should use. All right. I wish you luck, and I'll see you this week.